Bismillahirrahmanirrahim. In this lecture, I am solving problem 6.11 from the book Applied Thermodynamics by McConkey. The statement of the problem is a vessel of volume, a vessel of 0.3 cubic meter capacity. It means that in given data, while volume of the vessel is 0.3 cubic meter, contain a mixture of air and steam. Mixture contain of air plus steam. This is the mixture, which is 0.75 dry. Dryness means X. X is dryness fraction, which is given to us as 0.75. If the pressure is 7 bar, this is the pressure of the mixture of steam and air is 7 bar, which is equal to 7 multiplied by 10 power 5 Pascal or Newton per square meter. And the temperature of the mixture is equal to 116.9 degree centigrade. Convert this into Kelvin. So this is equal to 116.9 plus 273 Kelvin, which is equal to 389.9 Kelvin. Calculate the mass of water present. Required is calculate the mass of water, mass of dry saturated vapor, mass of dry saturated vapor, and mass of air, These are the required. Now, mixture pressure is given to us. First, we find the pressure of the saturated vapor. So, let's suppose this is TS diagram, temperature in degree centigrade, TV diagram. We can also draw TS, meter cube per kg. This is the saturation curve, and temperature is 116.9. Let's suppose this is 116.9 degrees centigrade. At this point, the vapor is dry saturated. First we find pressure at this point. The total pressure of the mixture is given to us, but first we find the pressure at this point. So we will use this. From this point to this point, pressure is called saturation pressure. So first we find this saturation pressure with the help of this temperature. So from solution, from saturated steam table, at temperature is equal to 116.9 degrees centigrade, find saturation pressure, and this saturation pressure is basically pressure of saturated vapor, dry saturated vapor. So if we check this temperature in table, this is not available. 116 is not available. This is saturated table, and 115 and 120. So we will interpolate between 115 and 120 degrees centigrade. So temperature in degrees centigrade available is 115 and 120 degrees centigrade. We have to find the pressure at 116.9 degrees centigrade, and saturation pressure here unit is kilopascal. Then we will convert it into bar. So pressure in kilopascal in front 116.9, 169.1 and 198.5. 169.1 and 198.5, and we have to find here the saturation pressure. So do interpolation. So third minus first divided by third minus second. 120 minus 116.9 third minus first. This is first is basically 115 divided by third minus second value is equal to third value 198.5 minus 169.1 divided by 198.5 minus saturation pressure. So find simplify this. So saturation pressure is equal to 180.272 180.272 kilopascal, because the value of steam table is in kilopascal, and convert it into bar. So 180.72 divided by 100, because 1 bar is equal to 100 kilopascal. So PS is equal to 1.80 1.80272 bar. This is the pressure of dry saturated vapor. Now total pressure of mixture is equal to pressure of air plus pressure of dry saturated vapor. So pressure of air is equal to pressure of mixture minus pressure of dry saturated vapor. So pressure of air, total pressure which is given to us is 7 bar minus 1.800272 bar. So this is almost approximately equal to 5.20 bar. This is equal to 5.20 bar. Now we have to find the mass of dry saturated vapor. Mass of dry saturated vapor. So formula for this is PV is equal to RT. PV is equal to MRT. PV divided by RV into T. So R per vapor is equal to 461.5 joule per kilogram per Kelvin. So putting values, so mass of dry saturated vapor is pressure of dry saturated vapor is given, is already determined by us 1.80272 bar. Bar is equal to 10 power 5 Newton per square meter. Volume is equal to 0.3 cubic meter divided by R per vapor is 461.5. Joule is equal to Newton meter per kilogram per Kelvin. And temperature is 389.9 Kelvin. This is given to us in the given data. So simplify this, multiply these two values and divide by these two values, which is equal to 0.3005, and this is kilogram. Newton will be cancelled with Newton. Per meter and per meter square will be cancelled with cubic meter. Kelvin will be cancelled with Kelvin. So this is per kilogram in numerator. So mass of dry saturated vapor is equal to 0.3005. Now we have to find the mass of water. So for this we will use formula. We know that as X is equal to dryness fraction is equal to mass of water vapor divided by total mass. So which is equal to mass of water vapor, and total mass is equal to mass of liquid plus mass of water vapor. This is liquid or water. You can write this as water. So rearrange this equation. So X into mass of liquid water plus mass of vapor is equal to mv. Now multiply by X, so X ml plus X mv is equal to mv, or X, this is mv, X ml is equal to mv minus X mv, or ml is equal to both sides divided by X. So here mv is constant, so 1 minus X into mv divided by X. So putting values here, So mass of liquid water is 1 minus x is 0.75 into mass of water vapor is equal to 0.3005. This is dry saturated vapor, mass of vapor 0.3005 kilogram divided by x is 0.75. Now this is simple calculation. Simplify this. So mass is equal to 0.1001 kilogram. This is mass of water. This is basically mass of water. This is mass of water. This is mass of dry saturated vapor. And now mass of air. So now mass of air is equal to PV by RT. So pressure of air divided by total volume divided by R, pressure of mixture or pressure of air divided by R of A multiplied by T. So mass of air is equal to pressure, this is 5.0 bar, so multiply by 10 power 5. Pressure of air is this value. This is pressure of air, 5.20 multiplied by 10 power 5 Newton per square meter. Volume is equal to 0.3 cubic meter divided by value of R per air is 287 joule per kilogram per Kelvin. Joule is Newton meter per kilogram per Kelvin, and temperature is 389.9 Kelvin. This Kelvin will be cancelled with Kelvin. Newton is cancelled with Newton. Per meter and per square meter is meter cube, will cancel with meter cube. So mass of air is equal to, simplify this, which is equal to 1.394 kg. So three masses were required. One is mass of dry saturated, which is 0.3005. Second is mass of water, which is 0.1001 kg. And third is mass of air, which is 1.394 kilogram. And this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.